Hi, this is Julius from DailyCode. I'd like to welcome you to this first introductory tutorial series on Z-Vector. This particular tutorial series will cover things such as the user interface, input and output, creating visuals, randomizing visuals, mixing visuals, as well as syncing visuals to either audio or to the beat. Before we move forward, I'd like to point out that many of the topics that are covered by this tutorial you will find also in written and illustrated form on our user forum. Just one more thing before we move forward. I sometimes get asked, what is Z-Vector? What does it do? Why should I use it? We originally created the software so that anyone, you or me, could pick up a depth sensor device such as the Kinect, a Kinect for Xbox 360, a Kinect for Xbox One, or any other supported sensor, and then to be able to plug that sensor into a PC and to be able to create a really fantastic looking visual in real time. And then to be able to take that visual and make it a part of any music video, dance performance, VJ, DJ performance, or any other type of show that you can think of. That's it. Let's move forward. Welcome to the first part of this tutorial series. This part will cover the user interface and input. For the purposes of this tutorial series, I've attached a Kinect for Xbox One into my MacBook Pro, so that's me right there. On the upper left side corner of your user interface, you'll find the mixer. Below it, you'll find buttons for randomize, and next to those buttons, you'll find some controls for camera, and below all of these, you'll find some more global controls. Most of these controls are covered in later tutorials. Let's move to the right side of the UI. Here you'll find input 1 and input 2. As I mentioned before, I'm only running a single Kinect for Xbox One into my PC. That's shown here on the left. If I was running a second one, it would be shown here on the right. Z-Vector supports 2 simultaneous depth feeds coming from supported depth cameras. Below the inputs, you'll find triggers. There are a few elements in the triggers section that you'd like to take a look at. First of all, you'll find the feed, as well as RGPD clips that are pre-recorded and come with your software. The same goes for input 2. If I had a second sensor running, I would have a second live feed shown here. And I could be playing back these clips on my second input. Below the inputs, I have control profiles on the left side of the UI. The control profiles are basically slots. They're basically visuals that come with the software. So in this case, there are presets that come with the software. And on the right side, you'll find backgrounds. In this case, they are just images, but they might as well be video, as Z-Vector supports texturing the depth map with either an image or a video. And then you find the banks to which you can save control profiles, RGPD files, or background files. Let's move forward. Welcome to the second part of this tutorial. In this part, we will be talking about creating visuals and outputting visuals. Let's first handle output. I click on output. Now, if I was running a second screen to my PC, I would probably want to monitor my output on that second screen. I could do so by clicking this button. But as I'm confined to a single screen space right now, for the purpose of recording this tutorial, I will just open up a window by clicking this button. Now let's first, before doing anything, make sure that we are editing the right profile. Z-vector essentially makes it possible for you to do something called A/B mixing. But whereas in more conventional VJ softwares, this means that you would be mixing between two video feeds. In this case, you'd be mixing between two 3D feeds. For the purposes of saving some GPU cycles, I'll click on live right now. This makes sure that I'm not rendering two outputs as I don't really need them right now. After that, I'll make sure that my mixer slider is on -100, meaning that I'm only editing profile A, and then I'll just make sure that I'm editing the right profile, so that would be A, which is currently active. Moving towards controls, this is basically the heart of the software. This is where you create your visual. The controls are made up of a few different parts. There's geometry, gradient, background, distort, post effects, and filter. These are the different parts of the UI that will make up the visual. Let's first play around a little bit with geometry. So I'll just put the count a little bit higher. And instead of using squares, I think, or horizontal lines or vertical lines, I think I will go with surfaces. Now, before doing anything, I think I will want to texture my depth feed with the RGB input from my camera. So I'll maneuver back to input, and I'll switch color to RGB. So, hi there. Now let's do something with color. I'll click on intensity. I'll pick a particular gradient that I like. Let's try light bicycle. And then I'll start to recolor the image with light bicycle. And as I move the slider up and down, you'll find that I'm recoloring the image with the gradient that I picked. In this particular tutorial series, we won't be covering background or distort, so I'm going to skip those right now and move directly to post effects. First, I'd like to explain the first slider under post effects. So this is the dry-wet slider. Dry-wet is essentially exactly that. It controls the amount of effects that gets applied to the image. So at 0, none of the post effects get applied to the rendered output. And at 100, it's only the affected image that gets shown on the rendered output. I'll leave that at 0 right now. I'll maneuver to the A, B, and C slots. I think I'll go with setting an effect on slot A. I think I'd pick edges. So effects in Z-vector are essentially GLSL shaders, which you can actually edit directly from inside the software. But this part we won't be covering right now. We'll get back to that in a later tutorial. You will find 3 slots that you can fill with different shaders. The other sliders in post effects do different things. The time slider is a variable that applies to some of the shaders, depending on how the shaders have been written. And the A, B, and C sliders apply to some particular variable inside that particular shader. So for example, when I move this slider here, it makes some changes to a single variable within that shader. I think I'll now move forward with putting a little bit of the effect on my image. I think I'll do a 50-50 mix. And after that, I'll apply some more of the effect on the image. I think that's great. Now let's move on to the last part of the UI. the controls UI. Filters are shaders that have been directly integrated into the software. So as I apply filters, I'm basically applying a shader that has been pre-written into the renderer. I think I'll do some soften, some feedback, and finally do a little bit of grain into the image. You should now have a basic understanding of how to create visuals in Z-Vector. The key lies, as with anything, in experimentation. Welcome to the third part of this tutorial series. This part will cover randomization. Randomization is one of the more fun features of Z-Vector. It's the capability of creating a completely random visual, or then to take a seed visual and then to create your random from there. Before we can do any randomization, it's important that we save the current visual. Let's maneuver over to Input, to an empty slot, under Control Profiles, and then right-click on an empty slot, choose From Current. I've now saved this particular visual. I'll just rename that one before we move forward. And then I'll apply that particular visual. There we go. Now, moving over this side of the UI, there are 4 different buttons related to randomization. The first one, on the left, will randomize half of all non-locked controls. What does locked or unlocked mean? I will get to that in a moment. The second one, from the left, will randomize 1/10 of all non-locked controls. The third one, from the left, is maybe my own favorite. Prior to randomizing 1/10 of all non-locked controls, it will first fall back to the original profile, therefore creating a kind of a loop. And the fourth one will bring you back to the original profile. Now let's try the third one, revert and randomize. This is where it starts to really get fun. Now that you have an understanding of how randomization works in Z-Vector, let's try locking. You can lock particular parts of the UI that you don't want to get randomized. So I'll just lock geometry, gradient, background, and distort. I'll leave post effects and filters open. And when I click this button, you can see that parts of the UI get randomized. You should now have a basic understanding of how randomization works in Z-Vector, as well as an understanding of how you can lock particular parts of the UI in order to prevent them from being changed. Let's move on. Welcome to the fourth part in this tutorial series. This part covers editing and mixing visual profiles in Z-Vector. Before we move forward with the tutorial, let's first release all the controls that we locked in the previous part. That is geometry, gradient, background, and distort. Now, as I mentioned to you before, in more conventional video and VJ software, the A/B mixer typically controls the blend between two individual two-dimensional video compositions or layers. In Z-Vector, however, the mixer actually controls the interpolation between the visual parameters, such as the camera setup, geometry, gradient, distortion, shaders, etc., that make up either profile A or B. The resulting visual transitions can be beautiful to behold, and they make up a very large part of the actual experience of using this software. Now, as we've already saved our visual on slot A into position A. Let's edit profile B. And let's pick a preset visual that we like for profile B. I'll go with this particular one, Cinderella Search. Now, as you can see, with A-B mixing, I can see two totally different visuals here. Now let's try dragging the slider from A to B. As you can see, the output is affected and mixed between these two visuals. You've now gained basic understanding of how to mix between visuals and how to benefit from the transitions that happen between them. Welcome to the fifth part of this tutorial series. This part covers animating parameters with audio input. Using audio is probably the easiest method for you to automatically animate variables and therefore affect visuals in Z-Vector. The first thing you need to do is to route some audio into Z-Vector. Go to Preferences, I/O, see that you've applied an audio input, and choose an audio input that you know there is some sound coming from. If your routing was successful, you should be seeing audio coming into your software. Custom algorithms split incoming audio into low, high, and noise. And the audio input is always under automatic gain control. This means that the software listens to changes in the audio environment and it tries its best to adjust for the best dynamics at any given moment. You can control the potency of the audio signal by dragging the audio dial left and right. This is important as the signal strength will have immediate effect on how any parameters that you might route audio to will act. Take note that any adjustments in the strength of the audio signal take place after the automatic gain control we talked about earlier. Return the dial to the center position by right-clicking on the controller. Now, making sure that both your currently active profile and mixer slider are set to A, navigate to Geometry. Click on the icon here to expose the animation controls for the geometry. On the exposed controls for the count parameter, click on low, high, or noise to route any of the three bands of your audio signal to the parameter. I think I'll route low. You might notice a gray indicator that will intermittently appear on the parameter slider. This indicator depicts the value of the parameter after the animation has been applied to it. Control the direction of the parameter by left-clicking on the minus, the plus, or the ping pong, which is the middle. Your render should now be changing according to the music. If you don't notice an immediate effect, you could try changing either the gain or going around the controls for Profile A, exposing and changing animation settings for any parameters that you want. Welcome to the sixth and final part of this tutorial series. This part covers animating parameters with beats. Animating parameters using audio is arguably not the tightest way to make your visuals in sync to the music. In cases where you'd like to have more control over your visuals, Z-Vector gives you the ability to sync to the beat. In Z-Vector there are three ways to set a tempo. You can either tap it in by using the tap tempo button, just type it in, or receive the beat via MIDI clock. For purposes of this tutorial, we will be using tap tempo. While listening to any music you'd like to sync to, Left click on the tap tempo continuously on each beat of the music for a few seconds. The BPM count should settle somewhere close to the actual count after about 3 or 4 taps. Once you have the BPM tapped in, it's time to synchronize the beat to the bar. While listening to your chosen music, left-click the sync button at exactly the downbeat, the first beat of the bar. This will reset the count and all synthetic signals used for animation. These synthetic signals are always visualized next to the BPM controls, and you should know that there are 2 types. The blue that go from maximum to minimum every beat, every bar, every second bar, every fourth bar, and then the orange ones that continuously loop from minimum to maximum, jump back to minimum when they reach the end of the beat, the bar, every second bar or every fourth bar. Now, just as the song playing in the background is coming to a close, we'll also be ending this introductory tutorial series on Z-Vector. As the very last thing that we do, let's route some of the synthetic beats to some of the animation controls inside the gradient. That's it. You should now have a basic understanding of how Z-Vector works. I hope to see you in the next tutorial series.